Okay, this is the example video for interpret two-way tables. Number one, a small town voted to decide if a road should be expanded from 2 lanes to 4 lanes. The two-way table below shows the results of the vote. So we've got our table here. Statement, calculate the relative frequency of the data to determine which association the two-way table suggests. Now, when it says relative frequency, we want to put percentages or their decimal equivalents into the table instead of the raw numbers they give us. So the first thing that you have to do for this problem is copy down this table, but without the numbers in there that they provided, just a blank one. And then we are going to, instead of these numbers, we're going to put percentages. Now, it was a little easier for me to show you how to do this on a spreadsheet rather than on paper. So I'm going to show you how to do it with a spreadsheet, first with just like a regular old calculator like you're used to, just like if it was pen and paper, pencil and paper. Then I'll show you how to actually use the spreadsheet to do the calculations for you. So we'll do this twice. First thing I'm going to do is just copy this table into my blank spreadsheet. So I have my Google Sheet open, and I will paste the table in there. That did not work. Let's try it one more time. Okay, there we go. And just make it look a little prettier. I'll put all my borders in there, and there we go. There's our table. Now I'm going to copy that table again, and I'm going to paste it right next to it. But this time I'm going to delete all the numbers because, like I just said, we want a blank one with no numbers in it because we're going to make a relative frequency table. We want to put percentages in each of these boxes. So how do we do that? Well, the first thing is we have to decide if it's a row relative frequency table that we want or a column relative frequency table that we want. We want a row relative frequency table in this case because what we care about is whether or not people favor or oppose the road expansion. We're not really concerned with what people, how the favoring breaks down by age and how the people who oppose it break down by age. That's not really what's important. What's important is how everybody feels about whether the road should be expanded or not. So we're going to do row relative so that we can tell if people do or don't want to have the road expanded or not more easily. So here's how we do it. Since it's a row relative frequency table, we're going to make each of these boxes into a decimal that is equivalent to the total of the row and what portion they are of that total. In other words, this says 33. We want to know what 33 is out of 91 because 91 is the total for the row. So if you have a regular old calculator and you're not going to use your spreadsheet because you're doing this on regular paper, you just get out a calculator and go ahead and punch in 33 divided by 91 and you'll get your answer. So here we go, 33 divided by 91, enter, and it says 0.36. Now we should just round to the nearest hundredth. We're going to round to the nearest hundredth because that's like the nearest percent. So I'm just going to put 0.36 into that box. So 0.36 right there. Okay. And then we can go on to the next one, and it's going to be 12 out of 91. So go back to our calculator, 12 divided by 91, and we get 0.1318. That rounds to just 0.13. So that's our next one, 0.13. And the next one is 46 out of 91. So 46 out of 91, 46 divided by 91, 0.505. That's going to round to 0.51. So that's the neutral column, 0.51. And then finally the row, since this is a row relative frequency table, should be 1.0. It should be 100%. If we add up 0.36, 0.13, and 0.51, it is 1.0. So that's how we do it. So go ahead and calculate those for the rest of these. 45 out of 96, 15 out of 96, 36 out of 96, then 10 out of 63, 29 out of 63, 24 out of 63, and finally 88 out of 250, 56 out of 250, and 106 out of 250. Okay, when you're done, this is what it should look like. You got 0.47, 0.16, 0.38, 0.16, 0.46, 0.38, 0.35, 0.22, and 0.42. Now, a couple things I want to point out, and it's that these three, that's the age 26 to 40 row, those don't actually add up to 100%. Why? Because we're rounding to the nearest hundredth, and these all happened to be rounded up. So if I actually added these together, I'd get 1.01. I'd get 101%. But it's just because of they all happen to round up. So that's okay. Similarly, if I added these three together, I would get 0.99, and they all happen to round down, and that's the reason that they don't add up to 100%. But those are acceptable rounding errors in this problem. So now that we have our relative frequencies, we can go ahead and answer our question. So let's put this table right next to our question, and we can start answering. All right, here we go. Let's look at all of these statements and figure out if they are true or false so we know which one to select. A, voters age 40 and over are least likely to favor road expansion. Okay, let's look at the favor road expansion column and find the voters that are 40 and over. Their percent is 0.16. That's 16% of them favor road expansion. Now the question is, are they the least likely out of all the groups to favor road expansion? How does their percentage for favoring road expansion compare to the other age groups? And they are the lowest percentage of all the age groups for favoring road expansion. 18 to 25-year-olds, 36% are in favor of it. 26 to 40-year-olds, 47% are in favor of it. So of all the age groups, the age 40 plus crowd is the least likely in this problem to favor road expansion. So A looks true. We should go through and make sure that B, C, and D are false so that we know we did the problem right. Let's look at B. The majority of voters are most likely to favor road expansion. Okay, well, that didn't break it down by group. That was just all the voters. So we can look at our total row at the bottom, and are a majority of voters likely to favor road expansion? The answer is no, because that's only 35%, and that's less than half. 50% or more, well, more than 50% would be a majority. So since that is 35%, that is not a majority, so B is false. Next, C says voters between the ages of 26 and 40 are most likely to oppose road expansion. So let's look at 26 to 40. Ages 26 to 40, those that oppose it, only 16%. So they probably don't oppose it. And the 40 plus group are also more likely to oppose it than they are. So C is definitely not accurate. It's not true. It's false. And finally, D, voters between the ages of 18 and 25 are least likely to favor road expansion. So let's look at the ages 18 to 25. How many of them favor and oppose road expansion? They have 36% that favor road expansion, whereas the 40 plus crowd, only 16% favor road expansion. So the 18 to 25 group are not the least likely to favor road expansion. The 40 plus group are. So that means that that's false also, and we're right in the beginning with picking A. And that's it. Now, I did say I was going to show you how to do this entire thing with a spreadsheet, so I'm going to show you that really quickly. Go back to where we copied the original table into the problem. Now, watch this. If I copy it one more time, and I go ahead and again, here we go. We'll copy it one more time, paste it in there. Again, I'll get rid of the numbers. I can do all those calculations that we did over here, and I can have the spreadsheet do it for me. Watch. If I want to divide 33 by 91, I could just type in equals 33 slash, that's the division sign, 91, and hit enter, and it tells me the number right there. And I can use this button up here to decrease the number of decimals. So I can decrease it to the 2 decimal places I want to. So I can use the spreadsheet as a calculator. But I also don't need to type in all the individual numbers. Instead of typing in equals 33 divided by 91, I can type in equals, and I can click on the cell with 33, and I can hit the divided by, and I can click on the cell with 91, and I can click enter. So what that just did is it said, oh, okay, you want that cell divided by that cell. So whatever numbers were in those cells, it divided them, and I got my 36%, just like before. Now, the cool thing is, if I go ahead and drag this down, it does the other cells automatically. You notice up here in the formula bar, it says B2 divided by E2, because the 33 is in column B, row 2, so we call that cell B2. And the total we wanted to divide it by was cell E2. So it said B2 divided by E2. Well, if you copy and paste that, or you can use this little corner thing to drag it down, it will automatically know that you want to do it for one row down because you put the formula one row down. So now it says B3 divided by E3. And the next one says B4 divided by E4. And the last one says B5 divided by E5. It automatically changes for you. And you could do that for all the other ones as well. Once you've got those numbers in there, if you want to actually add them together for the total, you can tell it you want to add them together by saying you want this cell to equal the sum of some other cells. So I say sum, and then I select all the other cells, I highlight them, and then that's that. It says 100, 100%. And again, you can apply that down. And there you go. They all say 100% because they're adding those together. So that's how you can do it with the spreadsheet, and it's super fast. So start practicing little things like that. But obviously, you can all do that with a regular calculator. When you get better at your spreadsheet skills, you'll be able to do that stuff really quickly. Let's go on to the next problem. Number 2, Miller inventoried the batteries in his house. The two-way table below shows the data he collected. Calculate the relative frequency of the data to determine which association the two-way table suggests. So again, we've got a two-way table with some totals, and we have to put the percentages in. So again, best way to do it for me, I'm going to copy this into a spreadsheet. There we go. And I will then copy it again and get rid of all the raw values so that we can put in the percentages. So if you're doing this on paper, again, all you got to do, you don't have to use a spreadsheet to do this. All you have to do is copy down onto a piece of paper the table just with blank spots, no actual numbers. Now I've got my calculator ready to do the calculations needed for my relative frequency table, but I need to decide if I'm doing a row relative or column relative frequency table. So let's go look back at our problem and see what we're actually trying to determine. These three statements all talk about whether the rechargeable or disposable batteries tend to be AAA or AA. That means we care again about whether the disposable is AAA versus AA, whether the rechargeable is AAA versus AA. Typically, that's again a row relative frequency table that we're going to make. So we'll go ahead and go back to our table. What is 18 out of 29? You do that calculation, 18 divided by 29. Put it into the calculator, 18 out of 29. And when you get that, you get 0.62. I'm going to go ahead and punch that calculation into the spreadsheet by putting equals 18 divided by 29. And there it is. It's already in there for me. So that's a little trick that you can use. You can have the spreadsheet be your calculator. You don't need to use a traditional calculator, but there's absolutely nothing wrong with it. And you see 0.62 right there. Now I can do the next one, equals 11 out of 29. So with your regular calculator, 11 divided by 29, enter, and you get 0.379. If I punch it into the spreadsheet, equals 11 divided by 29. Again, I get 0.38. That's what this rounds to. So it did the rounding for me because I reduced the number of decimal places that it could see using these buttons up here. Lastly, the total should be those two things added together. So I'll say equals that plus that. So I just clicked on the cells and said plus, and there it goes. It adds them together for me. I could also say I want the sum of those. Of course, you could just type those into your calculator. You don't need a spreadsheet to do this problem. You could say 0.62, so 0.62 plus 0.38, and you get your sum, which is 1, which is 1.00. So let's do the same thing for the rechargeable batteries. 7 divided by 21, 7 divided by 21, and you get 0.33 repeating. Okay, so equals 7 divided by 21. And then 14 divided by 21, so equals 14 divided by 21. 0.6 repeating, which rounds to 0.67. Again, 14 divided by 21. Looks like that in your regular old calculator. Has a whole bunch of sixes until it finally rounds it off to a 7 when it runs out of places to show you. And then finally the totals, 25 out of 50 and 25 out of 50. I really hope that you know that 25 out of 50 is 50% or 0.50, but if you punch it into a calculator, that's exactly what you'll get. So there you go. Okay. And that's it. And then you have the sums of those problems as well. They come up to 100%. Now we have everything we need to answer our question, so let's go ahead. First thing, none of the associations listed are correct. Well, we have to read through the associations to figure out if that's true. So let's see if any of these are correct. B, The rechargeable batteries tend to be AAA. Let's go ahead and look at our frequency table. What frequency of the batteries that are rechargeable, because that's what it's asking about, the rechargeable batteries, are AAA? Rechargeable batteries. Well, in the rechargeable batteries, 67% of them are AAA. So yes, the rechargeable batteries tend to be AAA. So B does look like a good answer. Let's read through C and D and make sure they are false. C says the rechargeable batteries tend to be AA. Well, I mean, that's the opposite of what we just said. The rechargeable batteries only have 33% of them as AA, so that's just not true. So C is false. And finally, D, the disposable batteries tend to be AAA. Well, let's see if the disposable batteries are also AAA normally. Go to the disposable column. Ooh, only 38% of them are AAA. They tend to be AA. So D is also false, which means B is the only right answer, and we're good to go. Next problem. All right, number 3. A class of 24 students recorded information about whether or not the students had brown or blonde hair and whether or not the students had green or blue eyes. Based on the information recorded, the teacher concluded that the students in the class who have brown hair tend to have green eyes. Which two-way table is a possible representation of the information recorded? First of all, it's kind of weird that there are 24 kids and they all have either brown or blonde hair and blue or green eyes. No brown eyes in the bunch, but let's set that aside for a moment and let's see which one of these tables represents this odd classroom full of kids. We are looking for the table where the kids with brown hair tend to have green eyes. So let's look for brown having more green than blue. Table W has brown hair right here in this column. And in the brown column, 5 have green eyes, 8 have blue eyes. That means more of the brown-haired children have blue eyes than green, so that's not our answer. Next table, table X. Here's the brown hair column. It has 9 children with green eyes and 2 children with blue eyes. So that means there's 11 kids with brown hair. 9 of those 11 have green eyes, and 2 of those 11 have blue eyes. So table X is definitely maybe one of the answers because brown hair, that column, has more kids with green eyes than blue eyes. Let's look at the other tables. Y. Now, table Y is just like W. It says that of the children with brown hair, 5 of them have green and 8 of them have blue. So again, that's more of the brown-haired children having blue eyes. That's not what we want. We want to have the brown-haired children tending to have green eyes in our table. And finally, table Z. That looks just like table X for the brown hair column. Of the children who have brown hair, 9 have green eyes, 2 have blue eyes. So, like table X, the children with brown hair tend to have green eyes in table Z. So is it X or Z? Well, what's the only other thing that the problem told us besides that it wants us to look for brown-haired children tending to have green eyes? It told us the class is 24 students. So which of these tables, X or Z, counts 24 students? Well, they both have 9 and 2 in the brown column. That's 11 students. So there should be 13 more students. There needs to be 24 total. So if I look in the blonde column, which of those columns adds up to 13? And it's table X. 5 plus 8 is 13, and then 13 plus 11 is the 24 students in the classroom. If it were table Z, we'd only have 22 students. We'd be missing a couple kids. So table Z would not be an accurate table. Table X could be. Number 4. An insurance company collected data from a class of high school sophomores on whether or not they have a cell phone and whether or not they have a car. The two-way table below shows the data collected. There's our table. Calculate the relative frequency of the data and determine which association the two-way table suggests. So one more time, we're going to make a relative frequency table. So let's turn to our spreadsheet. Now, as we use that spreadsheet, I want to reiterate, you don't need a spreadsheet to do this. All you have to do is copy down this table onto a blank piece of paper and just don't include the numbers in it because you're going to turn these numbers into percentages of their row or of their column. So I'm using a spreadsheet just to make this a little bit faster for the video. You can do this with a spreadsheet, but you can also just do it by hand. So don't be afraid to do that. I'm going to use the spreadsheet. You certainly don't have to. You would just mimic what I'm doing on the spreadsheet, but on a blank piece of paper. So again, take all the cells, take all the data, and just get rid of it. And so you have this blank table says cell phone, no cell phone total, car, no car total, and you just have no numbers in there. You write that down onto a piece of paper and you're ready to go. Now you just start putting in the numbers by dividing each cell by the total for either the row or the column, whichever is going to work for you to get the data that you want. So look at the problem and see what data you are looking for. If we look back at our problem, we can see these statements and we can read through them, and then it'll help us figure out if we want a row relative frequency table or a column relative frequency table. The choices here are this. A, those who have a car tend to have a cell phone. This says none of them are correct, so let's move on to C. Those who do not have a car tend to have a cell phone. And those who have a car tend not to have a cell phone. So each of these statements starts off with identifying first the group that has a car or that does not have a car. So those who have a car or those who do not have a car. So that means we want to isolate those who have a car and those who do not have a car. So we're doing, again, row relative frequency table. We're isolating the groups because we care about whether or not they do or do not have a cell phone. We care about first if they have a car, breaking down them. If they don't have a car, breaking down them. So this is a row relative table again. So let's take 12 divided by 18, 6 divided by 18, and then 2 divided by 7, 5 divided by 7, and then finally 14 divided by 25, and 11 divided by 25. When you do that, here are the results you get. Okay, so 12 divided by 18 gets us to 0.6 repeating, which is 67% if we round to the nearest percent, and then 33%, 29%, 71%, 56%, and 44%. Again, each of those are just dividing the cell here by the total in that row. 12 divided by 18, 6 divided by 18 turns into 67% and 33%. 2 divided by 7, 5 divided by 7 turns into 29%. That's rounded to the nearest hundredth, and 71%, again, rounded to the nearest hundredth. And finally, 14 divided by 25 gets us 56%. 11 divided by 25 gets us 44%. Now we are equipped to answer our question, so let's go back to it. A, those who have a car tend to have a cell phone. Is that true? Okay, we go back to our relative frequency table. Those who have a car, how many of them have a cell phone? 67% of them. So, of those who have a car, do they tend to have a cell phone? Yes, they absolutely do, and that is our answer. Let's go through and make sure we know why the other three are false. B says none of the associations listed are correct. Well, we think A is correct, so let's move on to C. Those who do not have a car tend to have a cell phone. Let's look up at that. Again, we're looking for those who do not have a car, and do they tend to have a cell phone? No car, no cell phone. That's 71%. So that's not true. Those who have no car usually don't have a cell phone. So those who do not have a car tend to have a cell phone. That's wrong, because those who have a cell phone and no car, that's only 29% of the people that don't have a car have a cell phone. So that's not accurate. And D, finally, those who have a car tend not to have a cell phone. Well, we just said that that was wrong in the very beginning when we looked at A. Those who have a car tend not to have a cell phone. No, those who have a car, only 33% of them don't have a cell phone. So A is definitely the right answer. Moving on. Number 5. A deli is offering a promotion where a customer can purchase a dessert item for 99 cents with the purchase of a sandwich, soup, or salad meal. The two-way table below shows the items purchased in one day at the deli by customers who ordered a meal. So we've got the sandwich people, the soup people, the salad people, and whether or not they got a dessert or no dessert. And then the total for each of those rows. And then the total for each column of the dessert and no dessert people. Calculate the relative frequency of the data to determine which association the two-way table suggests. And if we look at the suggestions that we have to choose from, they all are about the people who ordered a salad, a sandwich, or soup, and how they break down with dessert or not. So just like the other problems, this is again a row relative frequency table that we're going to make. So go ahead, draw a blank table with just the labels, no numbers, and then we will calculate the frequencies by dividing each cell by the total of that row, and we'll get a percent in there. So I will turn back to my spreadsheet. Again, you don't have to do this. You can just do it on paper with a regular old calculator. Here it is, 29 divided by 41. So let's see what equals 29 divided by 41, and we get that number right there. Next one equals 12 divided by 41. Over here, 56 out of 84. So we get 56 out of 84. So this will be equal to 56 divided by 84. I'm not rounding these yet. I'll show you how to round them all at the end if you are using a spreadsheet. But if you are rounding by hand, again, you always just look at the second number after the decimal. And then to see if you keep that number or bump it up, you look at the next number to it, the third number after the decimal, and round appropriately. Meanwhile, the calculation for this cell is 28 divided by 84. Have to hit the equal sign if you want it to calculate in a spreadsheet. 28 divided by 84. Here we've got equals 13 divided by 75. And as you keep going through this, you'll get more of them. Now, I'm going to show a couple people here a quick little trick for going even faster. Just in case you are advanced enough to understand a little spreadsheet trick, we will say equals cell B2 divided by cell D2. And I will say, don't ever leave cell D by using a dollar sign. If you don't know what I'm doing, don't worry about it. But if you know what a dollar sign does to a cell, I'm going to put it right there so that my reference to cell D does not leave. When I hit enter, it calculates that again, and I can apply that cell all the way over and all the way down. And then I can adjust my decimal places, and we're good to go. We have the relative frequency table that we want. So there we go. Let's now look at these relative frequencies and check out the problem. Those who order salad tend to order dessert. Is that true? Okay, well, those who order salad, how many of them order dessert? Only 17%. How many don't order dessert? 83% of them. So do the people that order salad, do they tend to order dessert? The answer is no. So we go down to here. Those who order salad tend to order dessert. False. B, those who order a sandwich tend to not order dessert. Okay, so let's look for the sandwich people and see if they tend to not order dessert. Go to our sandwich row. How many of them tend to not order dessert? Only 29%. So B is false because, in fact, the sandwich people do tend to order dessert. 71% of them order dessert. So B is false. Finally, C. Those who order soup tend to not order dessert. Those who order soup tend to not order dessert. We go back. Those who order soup tend to not order dessert. Well, only 33% of them did not order dessert. 67% of them did. So all of these seem to be false. D says none of the association listed are correct. And that's what we do. Next problem. Number 6, Joe surveyed 42 boys and girls to see how many of them like hamburgers and how many do not like hamburgers. He noted the results of his survey in the table below. So we've got our table here. Let's go through the fill in the blanks here. The majority of the people who either do or do not like hamburgers are girls. And then the majority of the people who do or do not like hamburgers are boys. The majority of boys do or do not like hamburgers. Okay, let's figure it out. The first statement, we're trying to figure out if the majority of people who do or do not like hamburgers are girls. So the majority of people who do like hamburgers are girls, or the majority of people who do not like hamburgers are girls. Let's look at the people who like hamburgers. Of the people who like hamburgers, 7 are boys, 12 are girls. So the majority of the people who do like hamburgers are girls, because 12 out of the 19 of the row of like hamburger people are girls. So the answer to the first one is it's the majority of people who do like hamburgers are girls. The majority of the people who do not like hamburgers are boys, because the do not like hamburger row has 18 boys and 5 girls. So of all those people, of the 23 people in the do not like hamburger row, a majority are boys. So majority of the people who do not like hamburgers are boys. Finally, the majority of boys, now we're looking at the column because we're looking at the boy column. A majority of boys, do they or do they not like hamburgers? Well, 18 of them do not like hamburgers, only 7 do. So a majority of them do not like hamburgers. Moving on. A company is releasing a new line of outlet and countertop air fresheners. The scents of the new line are Tropical Sunset, Island Coconut, and Vanilla Breeze. The company performed a market research study with 250 participants and recorded how many participants in the study preferred each type of air freshener. Based on the data collected, the company concluded that the majority of customers will prefer their Island Coconut scented countertop air freshener. Which two-way table is a possible representation of the data they collected? So we are looking for the data for a table that supports the company's conclusion that a majority of their customers will prefer their Island Coconut scented countertop air freshener. And remember, it has to have 250 participants. It's very important. So the first thing, let's look for which table prefers the Island Coconut scented countertop air freshener. Here are your choices: table W, X, Y, and Z. So this one's pretty simple. All we have to do is look for the data that shows that the countertop Island Coconut is the most popular option. So let's take a look at W. You've got countertop Island Coconut, that's 83. Is that the largest number in the table? Yes, it is. So that looks like a possible answer. Let's move on to table X. Island Coconut, 52. Well, that wouldn't be as popular as the outlet version of Island Coconut. So table X is not going to be an option for us. Table Y also has an 83 for the Island Coconut countertop, but that is, again, up to whether it adds up to 250 or not, as to whether W or Y is an option. They have different numbers, and it has to add up to 250. But it is possible because 83 is the largest number in the table, and 83 is the Island Coconut countertop intersection. Let's take a look at Z and see if it's also a possible option. No, only 7 for the countertop Island Coconut air freshener. So we're looking at W versus Y. They both have the largest number in the place where we want it to be, but there has to be 250 participants. So all we have to do is add these numbers together and figure out which one adds up to 250. And when we do that, we'll have our answer. When you add those together, you'll find out that table Y has 4 extra people in it. So table W is the one where all 4 of these numbers add up to 250, and it's the one with the most popular countertop Island Coconut section. Number 8, a group of 100 people were surveyed to find out whether or not they prefer ice cream, frozen yogurt, or shakes. They were also asked if they prefer chocolate or vanilla flavors. The results of the survey show shakes were the most popular, and chocolate was the most popular flavor. Which two-way table is a possible representation of the information collected in the survey? All right, so we want a table that has between the ice cream, frozen yogurt, and the shakes. We want shakes to be the most popular, and we want chocolate to be the most popular flavor. So let's look at these. Table W. Are shakes the most popular thing? The answer is no. We had more people choose ice cream than we had choose shakes. We had 28 and 24, so ice cream won there. That's not going to be our answer. Over here, we had shakes have 28, but only 16 vanilla. Over here, ice cream had 24 and 18. So what's more popular for table X? 24 plus 18 and 16 plus 28. Add them together and you'll get your answer. 24 plus 18 gives you 42. 16 plus 28 gives you 44. So table X works because 44 is more than 42. That makes shakes the most popular. Now we have to check and see if chocolate is the most popular in that, and sure enough, we have 28 for chocolate. So chocolate is the most popular flavor, and shakes are the most popular thing out of the 3 items. So table X works. Let's make sure we can see the problem with table Y and table Z. What's wrong with table Y? Shakes are most popular, 28 and 16, but look at the vanilla flavor. It's much higher than chocolate, so that doesn't make chocolate the most popular. That makes vanilla more popular, so that's not the answer. And the same thing with table Z. We've got shakes, again, the most popular thing, but vanilla is more popular than chocolate. So table X is the answer because more people chose shakes than anything else, and more people chose chocolate than vanilla. Number 9, the IT department at a company surveyed 320 employees to find out if they use a desktop or a laptop at home, and if they use an operating system A or operating system B. The results of the survey showed that operating system A is the most popular, and a laptop was the most popular type of computer used by employees at home. Which two-way table is a possible representation of the information collected from the survey? So again, we're looking for 320 employees, and we're looking for operating system A being most popular and laptops being most popular. So laptops more than desktops, and operating system A over operating system B with 320 employees. Let's look at our tables. Table W, is operating system A more popular than operating system B? Well, operating system A has 87 plus 118, that many people. That's clearly more than 59 plus 62. So table W definitely has operating system A as more popular. And then the laptops, how many people are using a laptop? 118 plus 62, that is clearly more than 87 plus 59. So operating system A clearly looks like the answer already. That's table W looks like the answer already. Let's go through the other three tables and see if we can find the problem with them. Table X, we have operating system A, 112 plus 87 is more than operating systems B, 59 plus 62. And again, 112 plus 62 is definitely more than 87 plus 59. So X is another possible answer. So W or X, which one might be the right answer? We have to remember the other piece of information. It has to add up to 320 employees. So if it comes down to W versus X, we have to make sure we find the one that adds up to 320. Let's look at tables Y and Z and see if they're also contenders. Table Y, 67 plus 92, is that more than 79 plus 82? All you have to do is get your totals to figure it out. Take a regular old calculator if you wish. You've got operating system A has 67 plus 92. That is 159 people. Operating system B has 79 plus 82. That's 161. So table Y has operating system B with more users than operating system A. That makes operating system B more popular, and that makes table Y the wrong table. Let's go to table Z and see if there's a problem with that one. Right away, right off the bat, we've got 112 for operating system A and 87 for operating system A's laptop. Operating system B desktop is 59. Operating system B laptop is 62. So clearly operating system A is more popular, but the laptops were supposed to be more popular than the desktops, and the desktops in table Z are 112 plus 59, whereas the laptops in table Z are just 87 plus 62. That makes the desktops more popular, which is wrong for this problem. So now we have to choose between W and X, and it's clearly just a matter at this point of figuring out which one adds up to 350. So go ahead and add the numbers together in table W and see if they add up to 320, not 350. So let's add them together. 87 plus 59 plus 118 plus 62 gets 326. That's too much. So table X had better add up to 320. 87 plus 59 plus 112 plus 62. And there we go, 320. So table X is our answer. One more, number 10. Morgan surveyed a sample of people at a basketball game to find out whether they expect the home team to win or lose the game. The two-way table shows the data she gathered. So we have a table right here. Select all the conclusions that can be made from the data. So we've got a lot of choices here. We can select more than once. We have to analyze each of these statements and figure out if it works or not. So let's start with the very first one. We'll go through one at a time. First statement. The majority of people who expect a home team loss are single game ticket holders. I'm going to read it again. The majority of people who expect a home team loss. So we're going to look for the people who expect a loss. We only care about this row right now. We're only looking at the people who expect a home team loss. We want to see if a majority of them are single game ticket holders. So in the expect a loss row, there's 36 season ticket holders and 14 single game ticket holders. So the majority of people who expect a home team loss are single game ticket holders? No, there's a majority that are season ticket holders, as a matter of fact, and this statement's not true. 36 out of 50 of the expect a loss crowd are season ticket holders. So let's move on to the next statement. The majority of season ticket holders expect a home team loss. Okay, let's go to the season ticket holder column. Okay, we're looking at the season ticket holder column. The majority of season ticket holders expect a home team loss. Is that true? Well, there's 80 season ticket holders, 36 expect a loss. That's less than half. So is that a majority? Absolutely not. So this statement is not true either. The majority of season ticket holders expect a win, as a matter of fact. 44 out of the 80 expect a win. So this is not true either. Third statement, the majority of people who expect a home team win are season ticket holders. Okay, let's go to the expect a win row. There are 55 that expect a win. The majority of the people who expect a home team win are season ticket holders. Is that true? We got 44 out of the 55 that expect a win are season ticket holders. So that works. A majority of the people who expect a win are season ticket holders. Next, a majority of season ticket holders expect a home team win. Absolutely. That's what we just determined a little bit ago. There's 80 season ticket holders and 44 of them expect a win. That is a majority. 44 out of 80 is a majority. Next one, the majority of single game ticket holders expect a home team loss. Okay, let's take a look at the single game ticket holder column. There are 25 of them. 14 expect a loss. 11 expect a win. So the majority of single game ticket holders expect a home team loss is true. 14 out of the 25 single game ticket holders expect a loss. So that is true also. Finally, the majority of single game ticket holders expect a home team win. No, that's the opposite of what we just determined. So that is not true. Only 11 out of 25 of the single game ticket holders expect to win. And that's it. So work hard on this topic. Good luck. Make sure that you read the lesson and have the lesson open in the background. There are lots of good written examples in the lesson that you can look at to help you complete the problems in this topic. Work hard and good luck.